My name is Lina Quesada, and I am the vegetable pathologist with North Carolina State University.
A lot of our field research with vegetable pathogens is done at the Central Crops Research Station in Clayton, North Carolina. At the station, we use pathogen nurseries to study soil-borne diseases. We do experiments related to host resistance, fungicide efficacy, and pathogen biology in the field. And once our field experiments are harvested, we take all the roots to our vegetable pathology building and begin all the post-harvest experiments.
And behind me is our mini sweet potato packing line that we have been using to try to do research and better understand what we can do at the packing house level to improve our disease control. So we have a dump tank, a conveyor belt for picking. We have this area where we spray the roots, and this other conveyor belt where we can do grading, rating, and picking.
For this post-harvest work, one of the diseases we focus on is black rot, due to the issues that it caused at the end of 2015. But I will let some of my lab members tell you about it.
Black rot is caused by the fungal pathogen Ceratocystis fimbriata. Black rot typically produces circular, dark lesions in the roots that can have a black center. Those black centers contain pathogen reproductive structures that are called perithecia. When you look at these structures under the microscope after growing the pathogen in culture for several days, you can see that they look like spikes. At the end of the spike, they produce a sticky substance which contains thousands of ascospore masses.
Those sticky ascospore masses can easily spread in the packing line if infected roots make it into the dump tank. This is an important reason why we are working to identify sanitizers and fungicides that are effective against this pathogen.
To determine which sanitizers are effective against black rot, we evaluated 4 commercially available products: Selectricide, Fruitguard, Sanidate, and Drytec. Sweet potato roots were surface sterilized and then soaked in a water treatment containing a sanitizer and C. fimbriata inoculum for 20 minutes. Treated roots were then stored at 85 degrees Fahrenheit for 14 days and rated for black rot incidence. After 14 days, roots inoculated without sanitizers or in the presence of a hydrogen peroxide-based product, Sanidate, had 100% disease incidence. However, the 3 remaining chlorine-based products were able to reduce disease incidence to 25% or less. Yet, it is important to note that these treatments were evaluated in the absence of organic matter that is present within dump tank water that can inactivate sanitizers and make them less effective. When using sanitizers, always follow product label instructions.
Due to the organic matter typically found in dump tanks, it may be more effective to apply sanitizers as a waterfall application or as a spray application in the packing line.
That is going to be particularly important when you're thinking about our organic growers or some of our growers that are exporting, since both in organic and export markets there are some restrictions in the use of conventional fungicides because of organic agriculture or maximum residue level concerns.
Sanitizers can help reduce pathogen inoculum levels, but they may not be sufficient in controlling diseases like black rot and rhizopus soft rot. Identifying effective fungicides that can be used in domestic and export markets remains a priority for us.
While we have been successful in identifying fungicides that are effective against black rot and other important pathogens of sweet potato, identifying fungicides that are approved for post-harvest use and that comply with maximum residue level limits established for sweet potato export markets has been more difficult.
Hunter is correct. After the 2015 black rot outbreak, we were able to secure an emergency label for the fungicide Myrtec, which is highly effective against black rot. However, MRL changes in the European Union, a key export market, made it so that our packers and growers are no longer able to use Myrtec post-harvest. We collaborate with the IRFOR project to identify Myrtec alternatives. Some products have shown efficacy against several pathogens of concern in sweet potato. Products like Stadium and Fruitguard have already been registered. Others, like Orius and Berecis, are currently under study in our lab. But something important to note is that certain active ingredients, like propiconazole, for example, we have had to abandon due to residue concerns. We are now actively monitoring residue levels in our fungicide efficacy trials to understand what are modes of applications and rates that we need to be using so that we can get disease management, but also fall beneath the MRL levels required by our export markets. Our data shows that for those active ingredients with established MRLs, for all of them except for thiabendazole and dichloran, we are falling below the MRLs for the European Union and the United States. Part of the reason why the thiabendazole and dichloran MRLs were established at 0.01 for the European Union for sweet potato is because there was no residue data available for these active ingredients in sweet potato. So our efforts may be helpful in revising some of those MRLs in the future. We hope you have enjoyed learning about our post-harvest sweet potato pathology research. If you have any questions, please don't hesitate to contact us. For more information, please visit our lab website.